Self-driving cars are vehicles that can navigate roads and highways without the need for a human driver. They use artificial intelligence, or AI, to process and analyze data from various sensors, cameras, and maps. In this section, we will explain how self-driving cars use these technologies to detect and avoid other vehicles and pedestrians on the road. One of the main components of a self-driving car is a laser rangefinder mounted on the roof. This device, called LiDAR, emits pulses of light and measures how long they take to bounce back from objects. This way, it creates a 3D map of the environment around the car. LiDAR can detect the shape, size, and distance of objects, such as cars, trees, buildings, and people. Another component is a camera mounted near the rear-view mirror. This camera captures images of the road ahead and recognizes traffic lights, road signs, lane markings, and other visual cues. The camera also helps the car identify the color and type of vehicles and pedestrians. A third component is a radar mounted on the front and rear bumpers. Radar uses radio waves to measure the speed and direction of moving objects. Radar can also detect objects that are hidden or obscured by fog, rain, or snow. These sensors work together to provide the car with a comprehensive view of its surroundings. The data they collect is then fed to an AI system that uses machine learning algorithms to interpret it. The AI system can recognize patterns in the data and classify objects based on their features. For example, it can tell if an object is a car, a bike, a person, or an animal. The AI system can also predict the behavior and intentions of other road users. For example, it can anticipate if a car is going to change lanes, if a pedestrian is going to cross the street, or if a cyclist is going to turn. Based on these predictions, the AI system can decide what actions to take to avoid collisions and follow traffic rules. The AI system can also communicate with other self-driving cars and traffic systems using wireless signals. This way, it can share information and coordinate actions with other vehicles. For example, it can adjust its speed and position to create gaps for merging cars or to avoid traffic jams. Self-driving cars use sensors, cameras, and artificial intelligence to detect and avoid other vehicles and pedestrians on the road. They are designed to make driving safer, more efficient, and more convenient for everyone. One of the biggest challenges for self-driving cars is how to handle the worst drivers on the road. Those who speed, tailgate, cut off, or ignore traffic rules. These drivers can cause accidents, delays, and frustration for other road users. How can self-driving cars avoid these problems and ensure a safe and smooth ride for everyone? The answer lies in communication. Self-driving cars can communicate with each other and with traffic infrastructure to coordinate their movements and reduce congestion and accidents. This is known as vehicle-to-vehicle, V2V, and vehicle-to-everything, V2X, communication. V2V communication allows self-driving cars to share data about their location, speed, direction, and intentions with nearby vehicles. This way, they can anticipate each other's actions and adjust accordingly. For example, if a self-driving car detects that another car is about to change lanes, it can slow down or speed up to create a safe gap. V2V communication can also help self-driving cars form platoons, where they drive closely together at a constant speed, saving fuel and space. V2X communication enables self-driving cars to interact with the road infrastructure, such as traffic lights, signs, sensors, and cameras. This way, they can receive information about traffic conditions, road hazards, speed limits, and optimal routes. For example, if a self-driving car approaches a red light, it can communicate with the traffic signal to request a green light or to synchronize with other vehicles to pass through safely. V2X communication can also help self-driving cars access parking spaces, toll booths, charging stations, and other services. By using V2V and V2X communication, self-driving cars can create a cooperative and intelligent transportation system that benefits everyone on the road. They can avoid collisions, optimize traffic flow, reduce emissions, and improve mobility and convenience. According to some studies, shared autonomous vehicles could account for 50% of all miles traveled by 2040 and reduce vehicle emissions by 90%. However, achieving this vision requires some challenges to be overcome. First of all, self-driving cars need a reliable and fast wireless network to support their communication needs. 5G technology is expected to provide the necessary bandwidth, latency, and coverage for this purpose. Second of all, self-driving cars need common standards and protocols to ensure interoperability and security among different vehicles and infrastructure systems. Third of all, self-driving cars need public acceptance and trust to ensure their adoption and integration into the existing transportation system. These challenges are not insurmountable. With the right infrastructure, regulation, and innovation, self-driving cars can communicate effectively with each other and with the environment to handle the worst drivers on the road and create a better future for mobility.